Hello everybody, now we have a presentation about asynctest, how to have easier unit testing for asyncio code.
Hi everybody. My name is Martin. I used to be a system and network engineer working on HTTP reverse proxy written with asyncio, and during that time I had a lot of trouble trying to write unit tests which were working correctly. So I decided to write a small library called asynctest, which provides a few features that you might find useful if you ever happen to be in the same condition. So during this presentation, I will present you the main features of asynctest. I will assume that you know what a unit test is, I hope, at least. And unfortunately, I won't have the time to explain stuff about asyncio. So if you are really not into what's a coroutine, what's a task, how an event loop is working, you might be a bit lost, and I'm sorry for that. So we'll talk about what I made to enhance the unit test package, standard package from Python. Most of what you will see is basically built on top of unit test. So it's like a drop-in replacement. You can use asynctest instead of unit test and it will work as expected. I will show you how I implemented transparent mocking of coroutine functions, which is probably the most useful feature of asynctest. And I will show you a few advanced features that might be also interesting. So let's start with a presentation of a test case. So as I said, async test case is built on top of unit test case. So it's just a class that extends the unit test version. And its main feature is that it handles the loop creation and termination for you for each of your tests. So every time a test case is instantiated and start to run, a new event loop from asyncio is started and running, so you are sure that your test is running in an isolated environment, so to speak. Obviously, inside of your code, you can access the instance of the loop just by using self.loop. So here is a simple example of test case. And what we can see here is that I can actually use a coroutine function as a setup function, or it works with teardown, or even your test case can be a coroutine. So you don't have to manually declare your coroutine function, then schedule it on the loop by yourself. It's all done for you. So you just have to focus on writing your actual test, and don't bother with the scheduling and stuff like that. It also works for cleanup functions. So basically everywhere you expect to be able to use a coroutine in a test case, it will work. Just a quick advice regarding that. Since it's fully compatible with unit test, setup and teardown can be actual functions, but I suggest that you always use coroutines because it will be way easier and you won't have to remember if you need to await your parent setup or stuff like that. So always stick to coroutines. Be aware also that it works for, the loop is created for the instance of the test case. So it won't work if you want to use a coroutine in setup class or setup module or those kind of functions. And someone opened a ticket to add this feature, and I decided to reject it because I feel like if you try to do that, you will probably break the single most important thing with test, which is try to keep the isolation as best as possible. So, however, if you really want to break this simple assumption, you can still do it. Here, what I do is that I'm in a situation where I need to use my customized version of an event loop. So, for instance, here with a setup class, I define it, and I can ask the test case to use the default loop. So in that case, rather than creating a new loop before the test, it would just call asyncio.getEventLoop and return the event loop that you set right before. One handy feature of test case is that it has some fail-safe for you, like this example, which was very common at first when people were using Python 3.4 without the async def syntax. You were using actual generators as coroutines, and in that case, you have the feeling that your test is okay and you won't see any failure in the result of your test. While actually it didn't run at all, because what it did here is that it saw a function that is prefixed by test underscore, so it will call it will return a generator instance, and will never run. So basically you won't see that your test is actually not running, and that's because you forgot to add the decorator asyncio.coroutine, which marks effectively this generator function as a coroutine. So what I did in that case is that I did a default check that if the loop did not run during the test will fail. So you will know that you made a mistake. If in some case you actually don't want to use a coroutine and be sure that the loop didn't, and don't want to check that the loop did not run, I've got this decorator called failOn, which has a few parameters that allows you to enable some of the checks and disable some others. We will see some of them later. So, one nice feature that's been added a few months ago is clocked test case. Because what we want to do is schedule stuff that will run probably in a couple of seconds or later, writing tests that will have to wait until the clock moves forward can take a lot of time, just wasted time. So clock test case helps you to control the time of the loop. So in this example, for instance, let's say that I've got a class which downloads the resource and we'll refresh it every 5 seconds. So here what I've got is that I set up my refresh and see that my downloader has never been called. Then I call self-advance, which will move the clock forward for 5 seconds. And as you can see, also I can do it with 10 seconds there. And what's interesting is that I actually had two calls during the await. So what it means is that the clock will not jump to the 10 more seconds, but will actually execute the seconds of callbacks and coroutine you expect. So it will work as well as if the clock was working and not like stuttering or moving fast and break. If we just moved forward the time to 10 seconds, we will only have one call and basically the call set for 5 seconds would be late, and the one scheduled for 10 seconds would not be scheduled at all. So in that case, you might want to answer that if you set schedule a callback for later, you want to be sure that it has been executed before the end of your test. We can check that with optional test called active handles that you can also enable with the failOn decorator. In this example, I use the decorator on the whole class, so it will apply on all tests, obviously. And the example in the bottom shows that I also handle the case where you cancel the handle and the callback. So now, more interesting probably is mocking. So I will show you a quick example. This example basically get burst URL from an URL, and I open a connection to the server. Then I write a HTTP request, then read the headers and read the payload according to the size I got in the header. So it's a bit dumb, but it's for the example. So here, obviously, what I don't want to do is to open an actual connection to a server in my test, so I want to mock that. So here what I do is that I define the function called createMocks. So I just will mock my stream reader and stream writer. which are the two objects returned by my open connection coroutine. As you can see, you can specify the spec as you would do with unit test, and in that case, the mock object would be smart enough to detect that one of the attributes that you are accessing is actually a coroutine function and not a plain function, so it will work correctly. So here, for instance, I just specify a few, what I expect to get as a result of my read and read until calls that were in my example here. So, as I said, it used the spec of the object you want to mock, so it detects coroutine and it's fine. Coroutines functions are actually mocked using an object class called coroutine mock, which basically will work correctly if you try is an instance of a coroutine or use the helpers function is coroutine, or also with the inspect module, so it will actually work almost as expected all the time. However, one drawback is that kind of an anti-pattern I see with asyncio is people actually saying that they are providing a coroutine in their API, while it's actually just a function returning a future, so it works exactly the same way in your code, but actually the function is not a coroutine, and when you will want to mock it, you will expect it to work as smoothly as in the example I showed, while actually it will not work. And one famous example is with AOHTTP, which does that a lot, or used to do that a lot, and made the mocking quite hard. So now that I know how I can create my mocks, what I do here is that I want to use them. So I use the feature of unit test called patch. Patch is basically will temporarily replace the symbol you want to use by mock. Here we've got open connection, which will be replaced by a mock, which will return as a result the result of my previously defined function create mocks. And in that case, what you have seen with the decorator is roughly the same as this example using the with statement. And what is important to see here is that the patch will still be active even if the coroutine yields to the scheduler, which means that basically the patch will stay enabled even if you go out of the coroutine and will affect other tasks running concurrently. In some cases, you don't want to have that, and you can so I did a feature that is an attribute to the patch used as a decorator. It won't work with the with statement, but it works with the decorator. And here I specify the scope of my patch to limited to the coroutine. And when the coroutine will yield and stop running, the patch will be disabled and re-enabled again right when the scheduler and the loop will decide to run the coroutine again. Okay, so one last feature, which is selector mocking. This is probably a feature you will never use because it's target the lowest level of asyncio. The idea is that in some cases you will want to handle low-level objects like sockets, file descriptors, whatever, and you will want to see if you can, if everything is working as expected, like you will get an event from the selector from the event loop. And so basically it's something you will use if you, for instance, want to add a new protocol or a new transport to the asyncio library, or if, for instance, you are trying to use Twisted on top of asyncio. So in this example, which is actually a really dumb example, but what I do is that I don't want to open a real socket, so I just use socket mock instead, and I can schedule a callback to the event. Something is ready to be read on the socket, and I've got an helper provided by asynctest which allows me to trigger the actual event. So I can manually define that I want to simulate a kernel event saying I can read or write on my file descriptor. So the socket mock works because I defined something called test selector, which is basically a wrap around the original selector. And it's pretty useful because it works with the mock file descriptors, but also with actual file descriptors. So you can use it as your main selector for your event loop without having to care if how your test will run. I provide a few different mocks, file mock, SSL socket mock, and all of them are basically just mocks compatible with test selector and providing a file no function which returns a fake file descriptor, so a fake integer. And they just use the spec of the objects defined by Python. So since it works correctly, if you happen to use mock files or actual file descriptors, I decided to enable it by default in the test case. And basically, it's already available if you use the test case class I presented you before. So one last trick is if you want to be sure that you have one call to remove reader after you set callback with add reader, or the converse add writer and remove writer. You can enable this check. We will ensure that everything is cleaned when your test finishes. And this is very important because you might have a lot of bizarre side effects if you happen to close a file without removing the reader and writer callbacks. Since they will be defined even if the new file descriptor is using the same value as a file previously closed. So just to wrap up, in the future, I would like to add the support of asynchronous iterators and context managers. This is a feature that is more and more asked because some libraries like IOHTTP are using asynchronous context manager a lot. I would like to add features to my file mocks, for instance, being able to specify a given buffer and let the user choose how we will consume this buffer. So to simulate an actual, what you would expect when you mock events running on the network. And well, I won't do that actually, but if someone wants to work on proactor support, which is targeting Windows, feel free to open a pull request. And for people who are actually using currently PyTest asyncio, which is plugin to PyTest, you can use asynctest with it, especially for mocks. That will be really useful and saves you a lot of time. And to finish, asynctest is actually used by people in production, well, to test their production code. Some of them are working at Cisco and Mozilla, and obviously my previous company, the company where I started this project, Always Data, use it a lot for all its tests. So thank you very much for your attention. You can read the docs and check the code on GitHub, and feel free to ask me questions or suggest some features or find bugs and whatever on asynctest. I would be glad to try to help you. Thank you. Okay, so I've got time for questions if anyone wants to ask. Yep.
What's the difference between original unit test and a synchronized test? You made it.
So the question was what's the actual difference in terms of speed when running with async test rather than unit test. Obviously async test is really slower than unit test because for each test that you start you will create a new loop and so open a lot of low-level kernel objects like the selector object and stuff like that. So it's quite slow, quite slower than unit test. So if you don't target, what you want to do is not running coroutines, you probably don't need to use async test and should stick to unit test, yes. Oh, and also you can mix unit test.test case and async test.test case anytime you want because it will always be detected by the unit test runner, so that's working. Yep.
Well, then related to that, can you actually reuse an event loop from another test when you know there is not going to be, sorry, there won't going to be any side effect by reusing it?
So the question was about reusing the same loop between several tests. Is that correct? Yeah. So you can improve speed by doing that. It's all right, but the issue will be that if you happen to have some events that are still that were not executed, or the loop will be in a state that is modified if several tests are running and using the same loop. So, for instance, if you happen to use clock test case and use the same loop for each test, you will most of the time have a non-predictable start time at the beginning of your test. Using clock test case, for instance, the first test that runs, if you call self.loop.time, you will get time of 0 because it's the beginning of the test. So if you use the same loop and several tests, the next test will have the value that is left by the previous test. So you can speed up by using the same loop, but most of the time when you write tests, you don't want to have tests that are that fast because it's not your main concern. You're more concerned by consistency and the actual work of your loop.
So you get a sense when you know it's not going to have side effects.
Yeah, when you know that it's not going to have side effects, you can't do it because it's, there is that feature that allows you to do it. So, any more questions? Okay, so I think I'm done. Thanks.